Good morning, students. Let us continue the same chapter, thermodynamics. In previous lecture, we have seen the definition of thermodynamics, what is temperature, and the zeroth law of thermodynamics. Now, in this lecture, let us see heat, internal energy, and work. Let us start with heat. Up to 19th century, a theory which is known as caloric theory was widely accepted. And according to this caloric theory, heat is a fluid, which is similar to our modern views. According to this caloric theory, heat is a fluid which is similar to our modern views. According to this caloric theory, heat, which is a fluid, is material in nature. Is material in nature, which is not correct. According to this caloric theory, the heat, which is material in nature, is conserved. And according to this caloric theory, heat, which is material in nature, is contained in object. This fluid is contained in object. This theory was challenged by an American scientist whose name is Benjamin Thompson. He was American scientist working for British government. He was appointed for drilling the barrels of cannon. Now let us consider this should be the cannon, and he was appointed to drill it with the help of boring tool. In the boring process, with the help of this boring tool, he drilled the cannon again and again, and he placed this cannon in a tank of water. This is the tank of water. He immersed this cannon in a tank of water again and again. He found that after some time, the temperature of the water in this tank is go on increasing, and this water is start boiling. He was very surprised, and he claimed that heat is not a fluid, but the origin of this heat is in the friction between the barrel and boring tool. The caloric theory told that heat is contained in object. What the caloric theory told? Heat is contained in object. He told that it is not contained in object. It is not something which is contained in object, but heat is something which is transferred in object. So this is our modern view, that heat is not something which is contained in object, but heat is something that is transferred in object. Now let us see what is internal energy. The second point is internal energy. In last chapter, kinetic theory of gases, we have seen the behavior of gas. Suppose this is container, and in this container a monoatomic gas is enclosed. The gas molecules, they are move randomly here and there with some velocity v. On account of its motion, they are having translational kinetic energy, and due to this translational kinetic energy, this gas is having internal energy. When the velocity of these molecules is increased, then the temperature of gas is also increased, then the pressure of the gas is also increased. And when the velocity or the translational kinetic energies decrease, then the temperature is decreased and also the pressure is decreased. Now, instead of this monoatomic gas, let us consider a diatomic or polyatomic gas. For the diatomic or polyatomic gas, they are having translational kinetic energy. In addition to this translational kinetic energy, they are having rotational kinetic energy and the vibrational kinetic energy. So for the gas, the internal energy is due to the kinetic energy. Instead of gas, if we consider the solid and liquid, for the solid and liquid, there are strong intermolecular attractive forces. And due to these intermolecular attractive forces, the solid and liquid, they are having kinetic energy. So when we consider the internal energy of solid and liquid, we have to see their potential energy due to the intermolecular attractive forces. Now remember that the internal energy is for gases due to the kinetic energy, and for solid and liquid it is due to the potential energy, not due to the kinetic energy. When the kinetic energy increases, the internal energy is increases and the temperature is also increases. This temperature is the characteristic of internal energy. So this is all about internal energy. Now let us see what is thermodynamic process and thermodynamic system. First, let us see what is meant by thermodynamic system. Thermodynamic system is a region of space having quantity of matter of a fixed identity. Now it is a region of space which is having quantity of matter which is having fixed identity. Suppose this matter is water or this matter is ice cream, anything around which we can draw boundary. Around this matter we can draw boundary, or in other word we can state this thermodynamic system, this thermodynamics system is a collection or group of object that can form a unit, which may have ability to exchange energy with its surrounding or environment. Now let us see the definition again. Thermodynamic system is collection or group of objects. The thermodynamic system is collection or group of objects that can form a unit. So this is a unit which may have ability to exchange energy with its surrounding. This is the surrounding. The elsewhere is the surrounding. Outside the system there is surrounding, and this is the boundary. Outside this boundary all is its surrounding or its environment. So this is the thermodynamic system. This thermodynamic system can exchange energy as well as matter with the surrounding, and depending on the exchange of energy and matter with the surrounding, the thermodynamic system are classified into three categories. One is known as the open system. If this thermodynamic system exchange energy and matter with the surrounding, then this is known as open system. The second thermodynamic system is closed system. This closed system can exchange only energy with its surrounding, and the third type of system is known as isolated system. This isolated system does not exchange energy as well as matter with the surrounding. This isolated system is not capable of exchanging energy and matter with its surrounding. So these are the three type of thermodynamic systems. Thermodynamics process. Thermodynamic process is a process. This thermodynamic process is a process in which thermodynamic process is a process in which the thermodynamic state of a system is changed. What is thermodynamic process? Thermodynamic process is a process in which thermodynamic state of a system is changed. In thermodynamic system, the thermodynamic state of a system is changed. What is meant by this thermodynamic state? The thermodynamic state of a system is defined by values of set of measurable quantities. thermodynamic state of a system is defined by values of set of measurable properties sufficient to determine all other properties. Now let us see what is meant by thermodynamic state. Thermodynamic state of a system is defined by values of state of measurable properties. Values of state of measurable properties. What are the major properties? Pressure, volume, temperature. These are the measurable properties. And if we define the values of set of these measurable properties, this is set, this is not a single quantity, then if these properties are sufficient to determine all other properties, then we say that that is thermodynamic state. What do we say? That is thermodynamic state. We will discuss this thermodynamic process in detail in next chapter. Till for that, thank you.